Assalamu alaikum. Today we will start with experiment number 5, but before we do that, let me just give you some instructions on how to write the experiments report. Number 1, you have to read this document about experiment 5 in details. The title of this experiment is Voltages in Circuits. Number 2, you need to find the values of resistance R and the voltage V across each combination of resistors for the circuits in figures 5.1 up to figure 5.6. You can do this by using the formula for the series connection. You can use this formula to find the equivalent resistance. And for the parallel connection of resistors, you can use this formula to find the equivalent resistance. For the first 3 figures, figure number 5.1, 5.2, and 5.3, assume the value of the battery as 3 volt. R1, R2, and R3 are equivalent to each other, and the value of each of them is 200 ohm. For the other 3 figures, figure number 5.4, 5.5, and 5.6, assume the following values. For the battery, 3 volt, for R1, 200 ohm, R2 is 400 ohm, and R3 is 700 ohm. After you finish doing the 6 figures, you need to write the report of your findings in step number 2, 3, and 4. You need to refer to the last page in this document, which is about discussion, and answer the questions in the discussion. And then after you finish, you need to submit a report using the assignment submission in Moodle, along with the other report, the one-page report, which you used to do during our class in campus. You can do the submission via Moodle or via email. You need also to attend your classes every Sunday at 5 p.m. Okay, let's start with the experiment. The title of this experiment is Voltages in Circuits. These are the equipment needed. You read this, you read the purpose, and I'll explain to you a little bit on the procedure, but you have to read it at home. So in this experiment, you are going to refer to this circuit diagram. In the circuit here, you can see 3 resistors, R1, R2, R3, connected in series along with the battery. This is the battery. Now, this is a very simple circuit. The values of R1, R2, and R3 are given in the first page of this document. We assume that R1, R2, R3 are equal to each other, and each of them is equivalent to 200 ohm. Now, what you need to do is you are going to calculate the values of R12, which is the equivalent resistance of R1, R2. Remember, R1, R2 here are connected in series. And then you need also to find the value of R23, which is the equivalent resistance of R2 and R3. Also, R2 and R3 connected in series. You need also to find R123, which is the equivalent resistance of R1, R2, R3. Also, these 3 resistors connected in series. Now, with this connection in series, you need also to find the values of V1, V2, V3. V1 is the voltage across R1, V2 is the voltage across R2, V3 is the voltage across R3. Unfortunately, we are not doing this practically in the laboratory, but we have to use Ohm's law along with the formula given in the first page about resistors or for resistors connected in series and in parallel to find the equivalent resistance of the combination, and also you can use Ohm's law to find the values of the voltages. V12 is the voltage across the combination R1, R2. This is the voltage V12. V23, this is the voltage across R2 and R3, and V123 is the voltage from this point to this point, the voltage across the whole combination, the three resistors. So this is for the resistors connected in series. So you need to write these values in the report with the details. I want you to tell me or to write in your report the way or the method or the formula that you use to calculate each of these quantities. I'm giving you only the value of the voltage of the battery, the EMF of the battery, which is 3 volt, the values of R1, R2, and R3. The other quantities, you need to calculate them again using Ohm's law and the formula for the resistors connected in series and in parallel given to you in page number 1. Now in figure 5.2, you need to use this circuit diagram, which is for R1, R2, and R3 connected in parallel now. So this is a parallel connection. Again, R1, R2, and R3, the same values, 200 ohm for each, and you need to find R123, V1, V2, V3, and V123, and you need to report this. For the next figure, which is figure 5.3, we have this combination of connection. You can see R2 and R3 connected in parallel, and the combination of these two resistors, the equivalent one is connected with R1 in series. So you need to find R23, R123, V1, V2, 3, V1, 3. Now for figure 5.4, in this 5.4, we have to use different values for R1, R2, and R3. We call them RA, RB, and RC now. So for RA, the values given here in the first page, you just need to change these. Instead of R1, you just make it RA, and which is 200. Instead of R2, you just make it RB. Instead of R3, you just make it RC. Okay? So RA is 200 ohm, RB is 400 ohm, RC is 700 ohm. So you need to use these values for the resistances in figure 5.4 and 5.5 and 5.6. So now RA, RB, RC, we know them. The value of the battery is 3 volt, and you need to find RAB. So RAB again is the equivalent resistance of RA and RB. RBC is the equivalent resistance of RB and RC. RABC is the equivalent resistance for the three resistors. And you need to find these values of voltages. So this is for the series connection. You do almost the same thing for parallel connection for this circuit, and for the last figure also, you do the same thing for this combination of series and parallel connections. After you find all these values of quantities in the 6 figures, you need to read this discussion and answer the questions here, like what is the pattern for how voltage gets distributed in a series circuit with equal resistances. You have to answer all these questions in the discussion. You make a full report and submit the report to me via Moodle. If you cannot, send it by email to my email address. You need also to write the 1-page report, which we used to do this when we conducted our classes in the labs. Okay. So, and also I expect you to attend my classes every Sunday at 5 p.m. If you have any question, you can ask me during the class, inshallah. Okay? That's it from my side. I'll see you during the class. Bye-bye. Assalamu alaikum.